Howdy, folks. Thanks for checking into Mr. Ulrich's Land of Biology. I, of course, am Mr. Ulrich. In this little notes cast, we're going to be talking about names. Now, we'll touch on common names for organisms, but we're really going to be focusing on organisms' scientific names and some of the guidelines that go into how scientific names are actually developed. As a self-proclaimed word nerd, you know what I'm going to do first. I'm going to dissect binomial nomenclature into its little bits and try to figure out what each little part means. Bi, of course, is the prefix for two. Nomi has to do with names, and here's nomen again, right, for the nomenclature. Clature is kind of like a system, I guess. And so binomial nomenclature means a two-named naming system. And you might say, hey, wait a minute. Here in Western culture, we're typically known by also a two-named naming system. And scientific naming is kind of similar. If you call my mom's house on Thanksgiving and you ask for Mr. Ulrich, you're going to get a whole lot of hands going up because I got a couple brothers, and one of my brothers has a couple sons. And so my dad's still kicking around. So there's still quite a few Mr. Ulrichs around. And you'd have to ask for a more specific name. And in scientific names, the two names are made of the genus and species of our Do Kings Play Chess on Friday, generally speaking, right? Domain, kingdom, phylum, class, order, family, genus, and species. And like we have a more general name, right? In my family, everybody, in my little nuclear family, everybody's got the last name of Ulrich, and then there's more specifics, Bruce, Kurt, and Tracy, right? And so we have a general name and a specific name, Ulrich, Kurt, right? That's actually genus and species where that comes from, general and specific. Now, as an organism, as a species, we are known as Homo sapiens, and that is our scientific name, genus Homo and species sapiens. Now, we happen to only have one species, not other species, but one species in our genus, right? There is only Homo sapiens extant now. But if we go back in the fossil record, we can see other organisms that are similar enough, their fossils are similar enough to put them in the same genus, Homo. They're still hominins, right? Upright posture, walking on 2 feet, opposable thumbs, large frontal lobe, set of teeth, all kinds of other characteristics. But if we look back into in the fossil record, we'll see other hominids like Homo erectus, who is similar enough, like I said, to be in the genus Homo, but different that, well, there probably wasn't any mixing of genes. Now, when we look at some modern humans in the fossil record, some people notice that some of them are very, very, very similar to Homo sapiens. But there are some structural characteristics that warrant putting them into a separate group. Those fossils were found in the Neander Valley in Germany, I believe. And Tal is Old German for valley, so anything that ends in ensis means coming from, and so sapiens is wise, Homo is man. So Homo sapiens Neanderthal ensis means the wise man from the Neander Valley, if you want to go all the way there. Now, if we're going to be taking organisms and assigning them into a particular species, we should know what makes one species different from another. John Ray is a pioneer of this. He was trying to get an exhaustive list of all of the different plants that grow in Great Britain. And when we go from town to town, people would trot out a plant, right? Here's our Christmas fern or whatever. And he'd be, oh, good, write this down. And then you'd go to the next town and people would trot out a different plant and call it a Christmas fern, or trot out the same plant and call it a different name. And so this was made tough. And so he wanted to kind of nail down what makes a particular organism particular. Right. And he is credited with coming up with the definition of it has to species. In order to be members of the same species, they have to be able to set up a self-sustaining population. Right, so they have to be able to interbreed, and the resulting offspring have to be reproductively viable, which means that they have to also be able to interbreed, and they have to be able to interbreed, and blah, 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 so we can have babies and babies and babies. Let's put this definition of species to the test. Is this a species, right? Should we be able to put every organism into a particular species? And the answer, of course, is, well, no. And if you know something about mules, maybe you know why this isn't a species. And I'll wait, write it in your notebook. Pause. Well, here's the deal with mules. Mules come from, well, you get a donkey that's feeling frisky and a horse that's feeling frisky, and you turn the lights down low and you place them very white, and lo and behold, you can get a mule. That's only can happen because the donkey and the horse genetically are similar enough that they can actually create, the sperm and the egg get together and they can actually create an organism that can survive. But there's enough mismatch that they have a little bit of trouble, a lot of bit of trouble when it comes time to making sperm and eggs, making their own gametes. And so you can take frisky mules, boys and girls, put them together, turn the lights down low, and it doesn't matter, right? They might go through all the motions, but they're not going to have any little baby mules. So this is not a species. We'd write it as Equus caballus, which is genus species for horse, cross asinus, right? Because donkeys are Equus asinus. The more we know about the guidelines that go into developing names, the easier it's going to be to get information out of those names and for us to develop scientific names of our own, which we're going to do in an upcoming activity. Anyway, scientific names are all Latinized, so they end in IS, ES, or US to your ears. There are actual rules about that, but we don't have to go into it. They are underlined or italicized if you're typing. And if you're handwriting, don't try to tell me that you have italicized it. You haven't. Can't write in italics. This is a pet peeve of mine. I hate it when newspapers don't do it. The genus, by convention, is always capitalized, just the first letter, not the whole thing's not all caps, don't yell at me. And the species is typically lowercase unless it's starting the sentence. The names themselves tell us a little bit. They're either going to describe where the organism was first found, like Neanderthal ensis, or who first named it. One of my favorite fish is the Haplochromis axelrodi, described first by Dr. Axelrod. Sometimes they will also indicate where the organism lives, both geographically, right, what part of the planet it's on, or where in the ecosystem it is, right, where in the environment. Is it tops of trees, bottom of trees, underwater, under rocks? Does it run? All those kinds of fun things. Speaking of running, that would be more of a behavior. And that's really what they mostly reflect, the morphology and behaviors of the organism itself. Here's a good old example, Haliatus leucocephalus, and if you know a little Greek, ancient Greek, maybe you know what this one is. I'll take it apart for you here again. Haliatus, like halite is rock salt, that's the salty fisherman, leuco for white, and cephalus for head. So who is the white-headed fisherman? Prominent white head, likes to go fishing. It's a bird. You know it well. It's our national bird, the bald eagle. And if you saw that picture and you heard the scream in the background, right? Ah! Whatever, I can't make the sound very well. That's not a bald eagle. Bald eagles actually peep when you hear that on the car commercials. It's actually our ubiquitous friend here, the red-tailed hawk. As I've said before, knowledge of combining forms is great. It can only help you with language. And we're going to use these combining forms to make scientific names of our own, because as adventure zoologists, if we discover a species, we get to name it. And in our next lab, that's exactly what you're going to be doing. Not adventure zoology, but you're going to be naming organisms. Anyway, you're going to choose characteristics and then use these Latin or Greek combining forms, put them together, and make names just like the genus and species of scientific names are done. So you've seen these before. Here's octo. You know what that one is, 8. Right, and puss for legs. The octopus has 8 legs, right? So we take these word fragments and as combining forms, put them together. Do yourself a favor, don't do more than 2. Use a prefix and a suffix and put the 2 together and make yourself a name of an organism, right? Rhino for nose, and ceros is horn. So the good old rhinoceros, known for having a horn on the end of its nose. Again, when it comes time for you to start making these words out of combining forms, you want to pick a prefix and a suffix. The prefix has the dash after it, like octo, and the suffix has the dash before it, like puss, and you put those 2 together. If I was going to name myself as an individual species, I would call myself Trichodops kerhonksenensis. Trichodo for hairy, ops for head, Ensis, like we said, for coming from, and Kerhansen. So I am the hairy head from Kerhansen. This hairy head from Kerhansen is going to sign off. That's enough for now. If you have any questions on this, please feel free to drop me an email, put a message in the comments. Other than that, I'll see you in the Google Classroom.